Hey guys, welcome to lesson 1.1, expressions and equations. In this lesson, we're going to do some work with word problems, trying to represent the information it gives us using math. We're going to write some expressions and equations, and that means we're going to have to look out for what in the word problem has some information that's either incomplete or just anything we don't know, but we wish we knew if we wanted to solve the problem. So the question to keep in mind is, where can I use a variable to represent what I don't know in a problem? Let's get started. So let's get some baseline definitions. Going back to middle school, let's talk about a variable. A variable is a symbol, usually a letter, representing a number. More than that, the number it represents changes depending on the conditions of the math problem. So in an expression might give us some of those conditions. So let's talk about it. In an expression, we have a number, a variable, or a combination of numbers and variables and operation symbols. It could look like this. It could just be the number 3. Any old number is an expression. It could just be the letter Y. Any variable like Y or X is also an expression. Or it could look more traditionally like this: 3 times Y plus 1. But here's the thing. At this point, Y could be any number. A lot of people get confused when they see the letters starting to appear in math, but all we're saying is that we don't know quite yet what the letter is. It's kind of just like a placeholder. Because we don't have any constraints, and we're going to talk about that in a minute, there's no limit to what Y could be. We just don't know. We don't have enough information. But if we have an equation, all of a sudden we might get some of that information. So an equation is basically like a math statement. It states that 2 or more expressions have equal value. You could just say 3 equals 3. You could say y equals 3. You could say 3y plus 1 equals 2x plus 3. Whatever. All of those are equations. But the point is, we're now setting constraints. We're putting limits on what a variable could possibly be. Now we're adding more information. So a constraint is a limitation on what the value of a variable like y could be. In math, we often use equal signs or those inequality symbols to set constraints on expressions. All right. So for example, 3y plus 1 equals 10. There's only one possible number that y could be. It's 3, by the way. All right, let's go into our word problems now. We're going to practice just representing this using, first, we're going to do an expression. Isaiah is going to the carnival. It costs him $15 for admission. So as we read in math, it's helpful if as soon as you see a number, you should probably underline it. It costs him $15 for admissions. It also costs him $2 every time he goes on a ride. Write an expression, not an equation, representing the situation if he went on 8 rides. Okay. So, first, we know that he went to the carnival. Let's just look at the story. We know that he went to the carnival. He spent $15. So, we can immediately just say $15 flat. What else do we know? Well, we know that every time he goes on a ride, it's $2. And he went on 8 rides. So it's $2 every time. What operation do you think that is? If it's times, it's multiplication. So we can represent multiplication with a dot like this. every time it's $2, and he went 8 times. So he went 2 times 8. Every time he went, it was $2, $2, $2, $2. And if we want to know how much money he spent all together, we're going to have to add, because putting things together is adding. So our expression could look just like this. $15 he spent for admission, plus every time he went on a ride, it was $2, and we know he went 8 times. Of course, you could do the math and figure out how much he spent in total, but it's not asking that. It's not asking for an equation. It's asking us to write an expression. This string of numbers is perfectly fine. So we're done. We're going to clear it, and we're going to move on. All right. Ooh. Layla is visiting New York. Every time she rides the subway, it costs her $2.50. One day on her trip, though, she took an Uber for $45. Write an expression representing Layla's transportation expenses if she rode the subway R times. R, not 8. Okay. There's no difference between this and the last problem, except we're replacing the number with a letter. So, first of all, let's look for the flat fee. She just spent an Uber, $45 in an Uber. So, it's over. So, we could just immediately get that out of the way. Okay. She spent $45. Ooh, I don't like that. Whatever. $45 on her Uber ride. And then every time she took she went on the there it is. Every time she rides the subway, it costs her $2.50. So let's represent that. Every time she rides, it's going to be $2.50. And how many times did she ride? It was R. So we're going to say 2.50 times R, and then we're going to put it together with the 45, and we're just going to put a plus sign in the middle. 45 plus 2.50 times R. We could just leave it like that, but it looks really sloppy. Not just because of my handwriting, but because, first of all, we don't really like putting the dot in the middle when we're using variables. We typically just like to put the number next to the variable. Also, even though when we're talking about money, we do like to write it like $2.50 and we leave the 0 there. When it comes to math equations, we don't like that 0 because it's kind of useless. So we can actually rewrite this as 2.5 and just put the R there, times R, and add it to 45. And we don't even need the 0.00. This is a cleaner way of saying the same thing you see in red. Okay, let's move on to one last example so then you can feel good going into the practice problems. Bryce wants fancy ice cream. It costs him $20 for a bowl of ice cream itself. It also costs him $3, let's underline, $3 for every topping. Write an expression representing the situation. Okay, well, let's just get it out of the way. He's going to spend $20 on his ice cream. And what are we going to add to it? We're going to add that $3 for every topping. But here's the thing. The first time we knew the number, Isaiah went on 8 rides. The second time we had a variable. Layla rode the subway R times. Now, well, I don't see a number or a variable. It doesn't really matter. You can make one yourself. We know that he's paying the $3 for each topping. So you can just make up for yourself a variable to represent the topping. I would go with, I typically go with T, but like T's look like plus signs. So I'm just gonna I'm gonna go with X, the classic. So X equals toppings. Oof. Or rather, X equals the number of toppings. Now, we have a variable for the number of toppings. So for every topping, every time he gets a topping, it's $3. Well, we already practiced this. It's going to be 3, the $3 times X. And like I said before, we could leave it like this, but it doesn't really look clean. So we're just going to reorder it, restructure it. Our final answer is 3x. We don't even need the dollar signs, really. 3x plus 20. This is how we represent Isaiah or Bryce's situation. All right, we practiced 3 times, 3 different word problems. We had it with the number, we had it with the variable given to you, and we had it with no variable